100,000 milli subscriber special, son. Congratulations everyone. We made it to our first milestone of 100 subscribers. I just really quickly, before we kind of get into it, I want to say thank you to everyone, and for all of your kind comments, and for all of the crazy views. You know that the robot video with the face that like emotes and things? You guys blew that out. Like, it's at like nearly 4K views now, and I'm really glad that you guys liked it. So yeah, thank you for getting me here, and I'm excited to see where this can go. Okay, what are we doing to commemorate this amazing achievement? We will be making our own YouTube plaque, right? Now, he's like, oh, it's so original. Yeah, well, it gets more boring, right? Because I want there to be lights inside of the plaque, but here's the thing. I want the lights to flicker. Yeah, here's the thing. I don't want to use an Arduino or a microcontroller. I want to build a circuit that is inherently used to flicker the LED with no code, no nothing, just by purely controlling the flow of the electrons and timing them with capacitance and the properties of capacitors and how they charge up and discharge, with the voltage source I'll be using, the resistors used with the capacitors, which will influence the frequency of the flicker as well. So my plan is to investigate that circuit, and then once I've found the circuit that I want to use, I want to put that into the YouTube plaque. Yeah, that's the plan. Well, in order to get this thing started, we need to do some research. This is an R&D project after all, so let's begin researching. Okay, so after some intense research, I have come to find a single circuit. That is the flip-flop circuit.
Okay, so for a basic, like low-level explanation of how a flip-flop circuit works, it essentially utilizes the fact that capacitors act as open circuits once they've been fully charged, and the capacitor is connected to the base pin of an NPN transistor. So because the capacitor is used as essentially the signal for the transistors, and the transistors are in charge of turning the LEDs on or off, what essentially happens is, as the capacitor charges up, the current stops flowing into the base, which tells the transistor not to run any current through the LED and around the battery. And by having two capacitors with both ends connected to opposite transistors, you end up with this kind of flip-flop motion where one capacitor charges up and the other is discharging. So one transistor is active and allowing current to go through one LED, while the other transistor is not active, and so no current is flowing through that LED. And this flip-flop or this like kind of alternating system here is what creates the is what the flip-flop part is, I guess. I don't know.
So the system should all be wired up now. So I guess we'll see if it works. It does not work. Okay, give me a second. Let me figure out why it doesn't work. Okay, what about now? Okay. Alrighty, so what I had done incorrectly before is I had connected the negative terminal to the collector and not the emitter. Basically nothing was happening, but yeah, I mean, this is it. So this is working exactly like the simulation. Charging up, they are allowing the capacitor slowly charges, it needs to turn on, and once the capacitor is fully charged up, this wire, this LED turns off, right? And the cycle then continues, and then as soon as this transistor turns, allowed to flow through this capacitor, which slowly kills the signal in here. Yeah, that still didn't really make any sense. So hopefully one day I'll be able to explain it properly. But anyway, for the purposes of this experiment, we were able to find a circuit that works, and in practice we can see that this also works. So the second last step now is to design a small compact YouTube play button which will house the system here as well as the battery. Alright, so here is my plan for designing the trophy itself. I was originally going to design it as a plaque to put on my wall. However, since I've been using a 9-volt battery, I'm a little bit worried it will be too heavy and I need to drill a hole in my wall and I can't be asked. So instead, I will be designing it to be something that I can put on my desk. So the plan is to have the triangle be kind of see-through on the button, and to have the circuitry behind that, so when the LED flashes, you can see that through the triangle itself. And so once that's printed, I'll let you guys know how it goes. Alright, and here it is. So it's pretty simple. It's essentially just a box, and so on here you can see I've got the 100,000 milli subscribers labeled here, and you can also see the mesh over the text and the play button here as well. So a couple of things I've added. This is just like a sliding piece of plastic that I can use to open the system and just keep everything nice and neat. And you can see inside is some paper, which I've put essentially to help diffuse the light a little bit better. This is the entire system. So you've got the play button, the battery, the circuit. Another thing is I decided to take out one of the LEDs and put a resistor instead, so that instead of turning one LED on and then the other LED on, this will just blink this LED, so it'll turn it on and then it'll turn it off and then back on. Riveting stuff, I know. So we can see that here. So all that's left is to put this inside this, and we're done.